Algebra 1. Welcome. Today we're going to be looking at lesson 4.2, using a product of powers and power of power property. Power of a power, yeah. So these names are kind of funny, but they actually describe them pretty well. So I think that's all we're doing today. Oh, they kind of, yeah, wait, we're actually doing power of a product as well. So there's a third one here. We should also have and power of a product. Power of a product. Whoops. Property, yeah. We're covering 3 properties today. All right, it's getting real, as they say. All right, so there's our objectives there. We're going to use the product of powers property, the power of a power property, the power of a product property. Now, one thing I want to show you today is that all the properties today you could probably easily remind yourself of if you forget them. And what I mean by that is if you were to expand these exponents, which means write them as multiplication. So a squared is actually a times a, times a to the fourth is a times a times a times a. And then you just convert it back to an exponent. Well, exponents signify repeated multiplication, and the exponent will be the number of times that you multiply it. And you quickly find out that you multiplied it 6 times. So that's the long way to do it. If you're ever like unsure, gosh, do I add or multiply? What do I do with the exponents? Just expand it and then see, oh yeah, that's what I do. So what do we do to 2 and 4 and get 6? Well, you add them up. Yeah, you add their exponents. So yeah, a lot of these with the smaller numbers, you can kind of really expand it kind of easily. But if you have big numbers, this property helps out quite a bit. Okay, now the key is that they have to have the same base. If they don't have the same base, you can't do this, okay? So z squared times z to the 7th, that's going to be z to the 9th. 5 to the 3rd, 5 to the negative 2nd, 5 to the 4th. Yeah, we could move that downstairs, but let's not do that. Let's just go ahead, since they all have the same base, add the exponents and get 5 to the 5th power. And let's evaluate that. 5, exponent 5. 3,125. Yeah, exponents get big quick. Okay, and then down here, be careful, because suddenly you're like, all right, when we're multiplying, we add. And then you start adding numbers, just plain old numbers. No, these numbers are multiplying. This is 6y squared times 3y to the 3rd times 2y to the negative 4th. You multiply the 6 and the 3 together, get 18. 18 times 2 is 36. That's what's out front. Now, the powers, though, you get to add the exponents. Y to the 1st. So I'm just going to leave it as y. Y to the 1st and y are equivalent. Okay. On part D there, you're going to multiply. Man, that's a lot going on, isn't it? You got this term here, and you're going to multiply it with all this term here. But don't lose sight of the fact that this is first off saying 2 times negative 5. So that's negative 10. Then we can combine things. So these are all multiplying, but some of them will simplify. For example, a to the 7th and a to the negative 2nd. If you multiply those together, it'll simplify to a to the 5th. Add them together. The b's will simplify to b to the 7th. And then the c's will simplify to c to the 1st, or just c. Okay, so that is the product of powers property. Again, if you forget it, just expand it and you'll see the relationship. Okay, let's turn the page. The next property is the power of a power property. Okay, so I'm going to expand this to show you how this works. A squared is A times A, but then we're going to multiply it 4 different times. So I have A squared times A squared times A squared times A squared. Well, how many A's do I have total? I have 8 of them. So we can rewrite it as A to the 8th. Well, what can you do to these exponents for a shortcut? You can just multiply them together. Yep, multiply the exponents together. Whenever you have power of a power, the powers are going to be right up against each other usually. You're going to multiply them together. So first example, A to the 21st. You're done quick. This one, parentheses, -2 to the 6th. Keep that parentheses there because it's going to get you the right answer if you do. If you got a nicer calculator, you're going to have to do parentheses, -2 to the 6th power. I'm going to do, in this calculator, I just do 2 negative, and it's going to raise the whole thing to the 6th power. So you get 64 for an answer there. All right. And then moving right along to the last one, and then we'll kind of combine them all together. That's where this stuff gets a little spicy. Okay, so power of a product. So you've got a product, you've got things multiplying together, raised to a power. Now they could have the dot with them, but they don't have to. I actually kind of prefer this to look like that. But anyway, yeah, so these are multiplying together, raised to a power. And what happens is you've got A times B times A times B. You've got AB times AB. And then you realize, oh, there's 2 A's, so A squared. There's 2 B's, there's B squared. Well, so how they describe this is you distribute the exponent to each power, okay? You distribute it to the bases on the inside. Technically, distribution is not that, okay? What I like to say is you're raising A to the 2nd power, you're raising B to the 2nd power. That's what you do. You raise each factor to the 2nd power. That's what you're doing here. Okay, so when you've got Z times A to the 3rd, it's going to be Z to the 3rd, A to the 3rd, just like that. Be careful on these with numbers. A lot of times people don't think of the numbers as being a base, but 4 is a base, X is a base, Y is a base. So we're going to get 4 squared, X squared, Y squared. And then evaluate 4 squared, which is 16, X squared, Y squared. And then we got it, okay. Be careful here because we still got 3 things here. The -2 with the parentheses is being cubed, A cubed, B cubed, and then if you punch that in your calculator, you'll get -8. In class, I had you guys do a few of these on your own and gave you, I checked around and saw how you were doing. But yeah, if you want to jump ahead and work some of these on your own and then go back to the video, be my guest. Okay, so for the rest of these, you're going to have multiple properties going on. And honestly, if you see that there's 2 different properties, usually you just pick one of the properties, do it, and then do the other one. You know what I mean? Just kind of do a property at a time. One property doesn't necessarily take precedence over the other as far as exponential properties. Okay, so on this one, I'm not seeing much to do except for taking that 3 to this product in here. So it's going to be 4 to the 3rd power. Now, what do you suppose happens when that exponent meets that exponent? You'd be exactly right. That's going to be power of a power. It's going to be 6. And then finally, we got that x at the end there, and it will combine with the other x. So we'll get 4 to the 3rd power, bless me. 4 to the 3rd power is 64. X to the 11th, Y to the 3rd. And I feel pretty good about that. Okay, on this next one, we're kind of stuck here, but over here, we can do the power of a product again. We'll have 2 to the third, y to the third. And then we're kind of stuck here. I see the y's will combine. I'll go ahead and do that. Those will combine to make 6. Add those up. The power of products property. Which one is it? Oh, product. Yeah, product of powers property. There we go. Okay. But yeah, y to the 6. But class, these are going to combine, but let's evaluate that first. Order of operations says do exponents first. That'll be 8, then times 3. And we get a nice answer like so. Oh, it's a good time to realize, to mention, I think, that there's a lot of formulas that involve multiple exponents and multiple powers and all this other stuff. So learning how to do this is not frivolous. It's used a lot in science and statistics and all sorts of things. So I just wanted to throw that out there. I feel like sometimes with math we're just kind of making trouble, just complicating life. But no. Almost every math that you guys do at the high school level is useful in a lot of applications. So anyway, I just wanted to throw that out. Okay, so the 2 goes to everything, including the 4, okay? Not the b to the third, though. It's outside the parentheses. So we'll have 4 squared b squared a to the 4th. And then from there, I'll calculate 4 squared is 16, and then we got b. The bases are the same, they're multiplying, so you add the exponents. B to the 5th, a to the 4th. And somebody asked me the other day, hey, don't you have to have the a before the b? That's pretty common that people do that, but there's no rule about that, so we're fine. If you want to swap them, multiplication has the commutative property, which means the order you multiply them doesn't matter, so you could flip that around if you'd rather. Okay, we got a couple more on the back. So same deal, minus rs, leave that alone, but then it'll be times r to the 2nd, s to the 6th. Be careful, it's easy to add those instead of multiplying, but power of a power, you multiply. Now we can add our exponents, but you might be looking at this saying, well, wait a second, r doesn't have an exponent. Yes, it does. S has an exponent as well. So when we combine these r's, the negative's just hanging out. But when we combine these r's, we're going to have 3 of them. 3 total. And 7 s's total. And on this one, before you get multiplication happy, again, we've got power of a product here. It's going to go to each of these. So it'll be 4 squared. Power of a power gets 10, power of a power gets 6, and then we're multiplying all that by negative 2ab to the 3rd. And before we multiply this negative 2 with the 4 squared, we got to square it. So that'll be 16 times the negative 2, negative 32, a to the 11th, b to the 9th. And there we have it. All right. So class, you want to practice this. We got a quiz coming up.